Welcome back to your pre-calc e-learning. I'm going to try to summarize everything you need to know about graphing an ellipse or a circle in under 10 minutes. So bear with me. I might be moving a little fast, but guess what? You can rewatch this as many times as you need to. So when we look at an ellipse, remember a circle is just a type of an ellipse, and I'll get to that a little bit more. You might see in your notes something looks like this. And man, that is a lot to break down and it's a little confusing. So I'm going to try to take a different approach. I'm going to just show you how to do this as easy as possible. So when we look at our example, one of the things we're going to have to go back to is remembering what H and K represent about and how you learned about H and K when you worked with parabolas in Algebra 2. So H and K were the vertex of a parabola. In my class, I always said H was a liar and K tells the truth. And I said H is a liar because it's behind bars, it's in parentheses. Well, the same idea is going to be here, except they're both liars, because what you'll see is that they both will be behind bars. So if I want to identify H is going to be the center of my ellipse, and it's associated with the X variable. If I want to identify K, I need to look at the Y value. It will be the center of the ellipse, and it will be the Y coordinate of that center. So when I look at X over here, I notice I just have an X squared. Nothing's being added or subtracted to that. So my H value of my center is just 0. When I look at my Y variable here, I see I have this minus 3. It's Y minus 3 squared. That minus 3 connects to the K value of our center of our ellipse, but remember it's behind bars, it's a liar. So I don't put in a negative 3, my center is at a positive 3. So if I want to graph this, I go up to 0, 3, and I've got my center right there. Okay. Now how to get the vertices and the co-vertices of an ellipse are based on looking at these denominators. Now, if you go back to those formulas in your note packet, 49, I need to rethink of this as a square. It's 7 squared. 16 is 4 squared. So when I'm trying to identify the A and the B value, I don't think about the denominators as 49 and 16. I think about them as a 7 squared and 4 squared. A is 7, B is 4. Now, if you're looking at your formula sheet, A is always the larger denominator. A will always come from that larger denominator. So what really is important, though, is that since the A value was under my X variable, I'm going to count from my center, I'm going to count in the X direction 7 in both directions. The value under my Y variable tells me how to count in the Y direction. So that's a 4 squared. So I'm going to count up 4. And I'm going to count down 4. Now, guys, what I have just created are my vertices and my co-vertices. I can connect these dots and voila, I have an ellipse. See, that wasn't that bad. We've already graphed our first ellipse, and it comes from knowing these 4 values. Where's your center? Look at H and K. Those are with the X and the Y, okay? So if I want my center, I have to look at the numerators. If I want my vertices, I have to look at the denominators, okay? Now there's one last thing, and this is what really makes the study of these conic sections so important, and that's the foci. If you've ever been to the Capitol building, either in Washington, D.C. or the one here in Annapolis, there's a reason to the dome shape, and it's based on using the foci points as the place where the speakers would stand. In a time before microphones, when both those buildings were built, everyone in the room needed to hear the speaker. So the dome shape helped them hear the speaker, but the most important part was that the speaker stood at the foci point. So if you want to find the foci point, you're going to use this equation right here, c squared equals a squared minus b squared. If you want to understand where that comes from, go ahead and watch one of the Khan Academy videos on foci points, and they explain that formula a little bit more in depth. So basically all you're doing is subtracting the denominators. Make sure you put the larger denominator first, because the last thing you want to do is take the square root of a negative number. So we take 49 minus 16, and I get the square root of 33. Now that value has to be added along the major axis. If you want to know which one's the major axis, just look at the larger axis. In this case, it's along the horizontal portion of the ellipse, because this is a horizontal ellipse. So I'm going to take the square root of 33, which I just need to estimate for my graph. Square root of 33 is somewhere between 5 and 6, and I'm going to add 5 in both to the right, and I'm going to add 5 to the left of my center. Everything is based off the center location. So my foci point is the center, which is 0. I'm taking the x value because my major axis is in the x direction, and I add the foci point. The k value stayed the same, it was at 3. And then I took my x value and I subtracted the foci point, which gives me these 2 points right here. Do I have to write the 0 plus 33? Nope. I could just write square root of 33 and a negative square root of 3 for those foci points. We are now going to look at another problem. If you look at this next example, okay, notice what's happening here. And I'm going to go to Desmos to help me with this. Notice these denominators are the same. So I get a 3 under both denominators. Okay, that's 3 squared. So my a value and my b value are the same. Well, think about what happens if the vertices and the co-vertices are the same distance from the center. And by the way, the center here, we still have nothing with the x, so the center is a 0. My k value is a 1. If I'm counting in each direction from 0 to 1, I'm counting 3. That means I'm going to go out 3, I'm going to go up 3, left 3, down 3. You've probably guessed it. This is going to make a circle. And obviously my drawings aren't that great, so let's go to Desmos real quick. So our center was at 0, 1, so I'm going to move that here, and you have access to this Desmo on your Google Docs for the week. Okay. The a value was 3, and the b value was 3. So you might be asking yourself, is this a vertical or a horizontal ellipse? It's neither. It's the special case of a circle. And notice something that happened here. The most important feature, those foci points became 1 point and the center. And that makes sense, because if you calculated the foci points using a squared minus b squared, okay, and I take 9 minus 9, that gives me a c squared of 0. So the focus point is the center point on a circle. Okay, do some more exploration of this. This is about as quick of a recap as I can do. Maybe we will look at one more problem, since I still have 1:15 before my 10 minutes is up. Let's notice this problem. If I analyze the h and the k value, then I'm looking at the numerator. Look at what's with the x, look at what's with the y. So with the x, I see a positive 1. So I know that's a negative 1. With the y, I see a positive 2. So that's going to put my center at -1, -2. I'm going to go ahead and graph that right there. Okay. And then I want to find my vertices. So I'm going to look at the values that are under the x. That's 36 under the x. So I know that connects to 6 squared. So in the x direction, I'm going to count 6. 1, 2, 3, 4, 5, 6, which puts me at a value of 5, -2. And then I'm going to count 6 in the left direction. And that puts me at a value of -7, -2. Those are my vertices. My co-vertices go in the other direction. I'm going to go up 3 and down 3. And so I have my graph that looks just like that. All right, thanks for being patient with me. Good luck. Let me know if you have questions.